Hello everyone. This is Praveen Chaudhary Bodapati. Uh, Today I am going to give a presentation on protecting sensitive information with database encryption along with my friend Sai Charan Vijayagiri. In this what we will cover is we will when to encrypt information, how to avoid encryption, where is the architecture to encrypt, key management, generic architecture and encryption techniques, implementation for specific databases like Oracle 8G and 9G, Oracle 1011i, SQL Server 2005. When these requirements for encryption we will need it, like GLBA to ensure confidentiality of customer records and information, state breach notification laws require notification if information was not encrypted, regulatory efforts impose stiffer fees and fines in the event that is a breach occurs and steps are not taken to approximately protect sensitive data. Payment card industry PCI DSS requirements 3.4 requirement 3 protect stored cardholder data. This is 3.4 render PAN at minimum unreliable anywhere it is stored. Strong one-way hash functions and truncation, index tokens and pads, and strong cryptography with associated key management process and procedures. Payment card industry PCI requirements 3.4 is continued like here, and if the disk compression is used rather than file or column level database encryption, logical access must be managed independently of native operating systems access control. Payment card industry 3.5 uh, encryption keys used for encryption of cardholder data against both disclosure and misuse. PCI DCS requirement 3.6 fully document and implement all key management process and procedures for keys used for encryption of cardholder data including the following: 3.6.1 generation of strong keys, 3.6.2 secure key distribution, 3.6.3 secure key storage, 3.6.4 periodic changing of keys, 6.5 destruction of old keys, 6.6 split knowledge and establishment of dual control of keys, and 6.1 prevention of unauthorized substitution of keys and replacement of known or sophisticated confirmation keys is 6.8, and 6.9 is revocation of old or invalid keys, and 6.10 is requirement for key custodians to sign a form stating that they understand and accept their key custodian responsibilities. It is one important thing is that PCA states cannot store MAC.strip and PIN or card verification code. Why? Threats, risk, and rationale for data encryption. Spectrum of threats to database information are T1 theft or loss of database system or storage media, T2 theft or loss database backup media, T3 theft or loss of OS backup media, T4 exploitation of direct database access, T5 database system compromise and database application of DB user account compromise, T8 application of middleware OS compromise, T9 exploitation of application with a restricted account, T10 exploitation of application with an unrestricted account. Encryption terms are like encryption algorithm, key, clear text, ciphertext, installation vector, symmetric encryption, asymmetric or public key encryption. What are the problems? Are like asymmetric encryption 100 times slower, and the symmetric encryption requires a shared secret, doesn't scale well, requires uh, keys for n people. Real world implementations are like use a hybrid symmetric, asymmetric, and hash. Provides both good performance and scalability. Doesn't require a pre-shared secret. Examples are like PGP, SSL by TLS, IPsec, S-MIME. Encryption alternatives. What are the alternatives that we have? And doesn't the information really need to be stored? Can the sensitive information be truncated? Can the sensitive information be stored as a salted secure hash? Can the sensitive information be stored only in memory or stored temporarily and then securely wiped? Homegrown encryption. Bad idea to invent encryption algorithms does not accept priority encryption. Acceptable algorithms are very difficult and require many past failures by the brightest and well-founded MD4 hash, Elix, Landman, DVD, CSS. Here we will show the standard asymmetric algorithms are of this kind. That is like the type algorithm is like DES and the type is block and the key is 56 and the strength is weak. That is DBMS, Oracle, MS SQL. And these are the algorithms and the types and keys and strengths and that's all what we have right now here. And This is full DB encryption. That means application there is an application and the OS file system database, and there is a clear test between them. And here the what are the lack of granular access control, performance impact, and limited key management. This is why this is not recommended actually. And another file of encryption is OS or file system encryption. And there is an application and the database and OS file system, and there is a clear test between them. And the same problems as full DB encryption area also we can face that, like lack of granular access control, performance impact, limited key management. This is also not recommended. Another encryption is like field level by TB or middleware, and there is an application and database, and there is a latest between them. And this is recommended actually because there is an granular access control, limited performance impact, and clear text communication should be encrypted. Field level by the application has less impact from other weak applications, and each application implements key management. Application level passwords and authentication. User password stored as salted secure hash, salt of 8 or more random characters, unique salt for each password, stored in clear with password. And we can see the example here. And the application passwords are like used to authenticate applications to other systems, must be retrievable by the application, stored with asymmetric or public key encryption, same issues as key management. From here onwards, my friend Sai will continue the rest of the part. Thank you very much.
Thank you, Praveen. The key management architectures. There are three types of those. Are the one is not recommended, those are recommended, and preferred ones. The not recommended were filled with the red columns, and the recommended and preferred ones were filled with the green ones. Let's see for the not recommended first. The key 0 to key 3, those are not recommended. The first one is storing and hiding keys in a software. The second one is auto description by the OS or FS. Third one is auto description by the DBMS. The fourth one is key stored in DB and readable by the DBA. The recommended ones are the key 4, key stored in FS on DB server and readable by DBA. The key 5 is stored in FS on DB server and not readable by the DBA. The preferred one, the key 6 is the preferred one, is stored in a client and application or a mid-tier server with manual access. As we discussed earlier, the key management threat matrix looks like this, and the key management threat matrix footnotes, explanations. The first one is if S, assume that the key is not stored in clear text on the system. The second one is with weak protection such as MS Windows. The third one, protection is only good as protection for the key. The section 2 is T6 and T7 versus key 6. If yes, key is not sent to DBMS for the description. The third one is K3 and K4 rules. The key is readable only by a single application account and the DBA. The account access does not include in the admin level access. The partial one, yes, in many cases, but not if description is automated by the application. For the encryption for the RKill 8i and 11G, the RKill database management systems obstruction toolkit, RKill DBMS crypto package, the recommended solutions, those are on the RKill transparent data encryption, RKill advanced security option, RKill database vault. The RKill DOTK checklist. We have 5 types. Use only the 3DES encryption rather than DES. Avoid for higher sensitive information. Use the DBMS crypto when available. Use a randomly generated key of at least 128 bits generated from the DES3 get key, and we use the for the get key to generate the 128 ones, and use a good source of encryption for the random seed generation keys such as GBE or random and Unix or Linux systems, encryption generic Enric and MS Windows. The RKill DBMS obfuscation toolkit. You see these examples. We can retrieve the information by using these characters, and also function with output returns, and also function produces with the raw parameters. Default null 6 values dangerous. And the RKill DBMS obfuscation toolkit it produces the description. The description procedure is as follows: the input string and key strings, the description string which involves the var characters, and the same as the above, and The DOTK DES3 generate key procedure. A key procedure is just like this. It uses the database abstract function toolkit, and which is in the place of the default value, and the seed string, which is where character also found in output. The RKLDBMS crypto checklist use either the AES 192 or AES 256 algorithm, and the use database crypto random bytes to generate random keys, not DBMS random. Use CBC. CBC means cipher block chaining mode. CFP cipher cipher feedback mode and OFB output feedback mode are both okay. Anyone is fine. Do not use ECB electronic codebook chaining mode. It is weak. That's why we don't recommend it. And use PKCS5 for the cryptographic padding rather than null padding. Actually, the Oracle DBMS crypto encryption sample encryption function is just like that by using this one. And the Oracle DBMS crypto encryption parameters are like features. The features are the crypto algorithm, which uses the options of DES, the DES like this, and the padding forms like a PKCS5 non-zero, and the block cipher is a CBS like that, and the DBS crypto encryption, which generates the bytes in the following way. The encryption for the my MS SQL Server 2005 key management hierarchy, a service master key, root top level key, semantic key, that is the semantic key. The one service master key is for installation and auto generated at the time of installation, cannot be directly accessed, can be recreated and exported, accessed by the SQL Server service account. And my SQL Server key management hierarchy is the key management hierarchy database master keys. Semantic key, one database master key per database, use it to encrypt all the same as the above, and copy restored or stored encryption with the password recommended, and the user keys may be a certificate, asymmetric keys for the semantic and generated as needed by the database. It follows the semantic structure keys. It comes from the mal database key, then it goes like this. Protection password. By avoiding storing passwords if possible, use LGAP or Active Directory if possible. Otherwise, use crypto APS. Like by getting these ones by generalized salt creates hash and generalized hash. MySQL Server checklist use either the AES 192 or those algorithms. Use randomly generated by the MS SQL Server. Avoid storing keys or passwords for the software. The summary of the concept is database encryption is increasingly an important and more often required security control. Second one is effective layer for the defense if properly implemented. And the third one is protecting keys hard to do and is most commonly weakness. Key management and encryption requirements needs to be defined early in the application requirements. Use these guidelines during the architecture design and implementation of the encryption. The resource and references, you know the references recommended by the MS SQL Server references. You can follow the link to get those, and those are the references, recommended Oracle references. Thank you guys. Thank you for your time. Have a nice day.